In this tutorial, we are going to go over Unreal's the basics of Unreal's blueprinting interface. Blueprinting is Unreal's visual scripting platform. So rather than typing code out, we are going to take nodes and visually connect them together to get our game to have interactive functionality. Before we start that, one thing to note is everything in Unreal that we can see on our level inside the viewport, they're all actors. If you remember back to our discussion on object-oriented programming, we talked about a concept called inheritance, where we can have a base class and we can have children of those class. Everything that we see here is a child of Unreal's base actor class. We can see the type in our outliner, for example. Whenever we click these things, it says landscape streaming proxy. The drone is a static mesh actor. The player start is of type player start, but all of these are the children of Unreal's base actor type. One of the things that basic actors have in Unreal is a transform, and we can see all of these assets have a transform. To create a blueprint, all we do is we right-click anywhere in our content browser and we select Blueprint Class. This will pop up a little dialog box that lets us first pick the parent class. There are a few options here. You have Actor. This is the most basic type and one we're going to end up using a lot. Then you have Pawn, Character, and Player Controller. All of these come together to create our player character. We will explore this more while we start building our first-person player character. Then we have the game mode base. In Unreal, we have to set a game mode. A game mode defines the rules of our game, and this is the class that we put that in. Again, this is something we will explore later. Finally, you have actor and scene components. We probably won't end up using these classes, but they're also very commonly used. You could click this drop-down box to see all the classes, and you can see there are a ton. You can even make custom classes if that is something we choose to do. In this class, we won't be using that. However, as you guys go into your studios, that is something you might end up doing. For now, I'm going to click Actor, and you can see it made a default actor class. As with the naming convention, we are going to say BP first, underscore, and then the name of our actor. I'm just going to name this Test, but name it relevant to whatever your actor is. We can take our actor and drag it onto the screen. And you can see in my outliner now, this actor exists here. This actor doesn't currently consist of anything, but it does exist here. To edit the actor, all we do is double click. And after a short loading screen, you can see our actor editor window pop up. Now, back to our discussion on object-oriented programming. A class consists of three basic things. It has a name, in this case BP test. It has data, and it has functions or functionality. The data of our actor can come in two types: components and variables. We will go over variables next week, but let's talk about components right now. When we look at the hierarchy of our components, you can see that we have the actor itself and the default scene root. We can add components by hitting the Add button here. So there are many different types of components in Unreal. Some of the nicer ones to use just for prototyping are these basic models here, plane, sphere, cube. So if I click on sphere, you can see we've added it to our actor. We can name the sphere. I'm just going to keep it a sphere. I can hit the compile button. And now if I was to go back to my scene, you see our sphere propped up here. In here, we can change the scale of our sphere. We can rotate it, although that's not something we'll visually see because it's a sphere. But when we compile it and I go back, you can see my sphere has increased in size. Another thing we can do is also take the sphere and drop it to where our scene root is. This will make our sphere the default, the root object, and everything else can connect to that. But I am just going to leave the default scene root as our base object. I'm going to delete the sphere for now, and I'm going to go back and add a static mesh, and I'm going to call this SM drone. And in the right-hand side details panel, you can see all the options for a static mesh, and this is true for any component we add. All the options will always be on the right side. I'm going to select this, and I'm going to search for my SM drone. We can compile it. And now you can see our drone is a static mesh in this actor. There are many other components you can add to an actor, and a good way of thinking about an actor is it's just a set of components with one single functionality. Now, let's direct our attention to the middle of the screen where we have our actor viewport. We can navigate this viewport very similar to how we navigate the world viewport using right-click. You can tap F to focus. You can hold Alt and left-click to orbit an object, and it has the exact same controls as the viewport in our level. On top, we can see two more tabs. Construction scripts, we will get to this in another class, and the event graph. The event graph is where our programming actually takes place. By default, all actors come with 3 events that Unreal just has. We have event begin play. Begin play runs once, and that is when the game starts. The use of this function is to set up variables. For example, our player might have 100 health. So every time in begin play, we will set our health to 100. So this means when we start the game, the health starts at 100. We have actor begin overlap. We will look at this in a future date when we learn about collisions. But when an object collides with our actor, this function is executed, and that is what its use is. And finally, we have event tick. On every frame our game runs, not only does it render new images, but it also runs code. This event tick will run every single frame of our game. We will see begin play and tick in action in just a little bit. The basics of this interface is that you can hold right-click to pan around. You can scroll in and out using the scroll wheel. When we look at one of the nodes, which is what these are called, there's 2 types of pins. Pins are these things in the corner that we can click and drag out of. We have an execution pin, which is symbolized by these triangles here. When we hover over it, it says exec, which is execution, and we can drag them out. An execution pin determines the order of what's going to happen. The other type of pin is a data pin, and this is represented by circles usually. Unreal color coordinates their data types. So green is a float. We'll talk about variables next week. A float is basically a decimal number. Blue usually refers to an actor of some kind. So this, in event begin overlap other actor, refers to an other actor class. So when something collides with our actor, this pin is going to have a reference to the actor that collided with us. Again, we will see the use of this in a future class. You can always right-click anywhere, and that opens up the Add menu. Here we can search for different Unreal nodes by typing. So if I was to type Add, for example, it populates with an Add node. Or we can click through these drop-down boxes and get a good understanding of what all categories of nodes exist in Unreal. One nice thing about Unreal is when we drag out an execution pin, it also pops up the search bar. However, this list is now a little smaller, even though it doesn't look like it. It's a little smaller, and it contains only relevant actions. If we wanted to see all the actions, all we need to remove is this context sensitive. So one example of that is when I search for add and I add it, you can see add is gray over here, which represents that it doesn't have a data type. If I take this delta seconds, which again green represents float, which is a decimal number, and I search add, we can see it populated with a green add function, which if we hover over here says it takes a float, it takes another float, and it has another float, which is the addition of the top and the bottom float. You can delete anything by just hitting delete. Before we get into using a simple node to like visualize what begin, play, and tick does, one other cool feature in blueprinting is comments. All we do is hit the C button and it pops up a comment block. Here we can type things. And we can move it around, and we can also change its size. Comments are very useful for remembering what we are doing. For example, if my blueprint starts to get very large and I have to zoom out, you can see that we can always see our comment, and it helps us navigate through larger scripts. You might not use commenting all the time, but just know it exists. And as you start making complicated scripts, commenting will help future you understand what you did before. We can also click on the comment and then change its font size, which will help us see it better if it's, if we have to zoom out very far. And we can change the comment color. Change the comment color is very helpful, especially as you start to have a lot of comments. It just makes things visually look better for us. I'm going to delete this comment right now. Now let us look at one very simple Unreal node that you are going to use a lot, and that is print string. So when I search for print string, it automatically gives me the node and it connects the two. The reason it connected the two is instead of right clicking, I dragged this out and I searched for print string, and you can see it connects it. So this execution here means that when the game starts, this pin is going to fire, which is what we are going to call executing, and that will lead us to this print string that is going to display this text on screen. We can click on this text and change it to whatever we want. I'm just going to leave it as hello for now. And when we compile, if I was to go back here and hit play, you can see on the top for just a second it displayed hello. That is because when the game started, this pin fired, went into our print string. The print string said display hello, which is what was displayed on screen. We could, for example, control copy and control V to paste another one of these, and I'm going to call this hello 1 and this hello 2. I will drag hello 1 into hello 2. So now what this reads as is on begin play. First we're going to print hello 1, and then this execution is going to go into hello 2. So when we hit play, what we're going to see is hello 2 and then hello 1. The reason it's in this order is because it printed hello 1 first, and then it pushed it down and printed hello 2, which is why hello 1 is on the bottom, because it printed first. So that's a good way of saying what event begin play does. It lets us do things once. Let's look at the tick event now. So I'm just going to take this hello 1 print string and connect my event tick to it. We can delete a connection by just holding Alt and clicking on the connection. That is a very simple way to do it. We can also, instead of deleting the connection, hold Control, which will let us move the connection, and we can just move it onto event tick. Now remember, event tick runs once every frame. So what we're going to see when we run this is it's going to keep printing hello 1. You can see it's just printing it very quickly because we're running frames very quickly. And it's just going past the screen. We can come back here and delete this for now. One very nice thing in Unreal about print strings and what makes them so useful, and something I encourage you guys to use all the time, is its ability to help us solve problems, also known as debugging. There are a lot of debugging tools in Unreal. We might look at some of them later, we might not. But print string is your most reliable tool that we have. What is great about it? When we look at what print string takes, which is this pink color variable, and when we hover over it, it says it's a string. A string is basically just a set of characters to make a sentence or anything like that. We have something like our delta seconds, which, just for reference, delta seconds gives us the amount of time in seconds it has taken us to render that particular frame that we're on. This will usually be a very small number. If you think about it, games run at 60 frames a second. So our delta seconds will be something very small, because we would get 60 of these delta seconds ideally in one frame, or within 1 second. Now the nice thing about strings or print string in Unreal is, let's connect this back to the tick. And if I was to take this delta seconds and plug it into string, even though these two are of different types, when we try it, you can see that Unreal lets us do it, and on the little help box it says convert float to string. So when we do this, we get a little nice conversion node that converts. It takes in green and it outputs our string. So when we hit compile and we go back here, instead of saying hello 1, now we're just getting a list of numbers. And what this number represents again is the amount of time it has taken for us to render that one frame. You would have noticed that it starts off with slightly bigger numbers like 0.1. And now once my game is up and running, it is rendering really quickly at something like 0.02, so about a tenth quicker than when we started. And these numbers are just flying by because, again, our game is running really fast, and so this is what it represents. This is very helpful because as you encounter issues, they might be with very random objects or random variable types, and when we're not sure of something, just print it. Printing is the most useful tool that we have for debugging, not only in Unreal, but throughout programming. Printing is probably the most primitive, but also the best way to start debugging, because it lets us really see what is happening step by step in our program. Now, one thing that's kind of not helpful is when I've hit play, it is just a bunch of numbers. There's no context to this. To help with that, we can use a function in Unreal called append. So we right click and we can add append. Oops, that is the wrong append. Actually, this is a good time to talk about this. When I search append here, you can see under list, we got the append function. This is not the append that I want. I want a string append. So one good way of doing that is taking the string value, and then now we're in a context sensitive string search bar. So when I search append, instead of the list popping up, you can see under string I got append. Again, very useful thing in Unreal. All append does is it takes two strings or more and it puts them together as one string. So in this case, I could say this frame took, and you can always add a pin. You can see when I add a pin, it adds another pin to it. We can keep adding pins by clicking this button, or we can right click on a certain pin and remove it if we don't need it anymore. So in this case, I will say this frame took the amount of seconds that it took, seconds to render. And we are going to plug this right into our print string. So let's think about what this means. On every frame, we are going to create a small string that says this frame took the amount of seconds that that frame took, which is a number, seconds to render. So this should say this frame took, this frame took the amount of seconds to render. And then that's going to print on screen now every frame. And now you can see this has a little more context to it. Again, ideally you're not going to use such big strings. I just wanted to illustrate this concept that we don't just print out values, but we can use the append function to give them context. And as we're debugging, this becomes a very useful tool in our arsenal. Thank you for watching.